Okay. Hi, everyone. My name is Dario Agudelo. I'm from Colombia. My city is Manizales here, between the main cities of Colombia. Yeah. I work in Universidad Autónoma de Manizales. And the ICTP provide me some resource for stay here. And today I'm going to present one work with networks for co-authorship of science articles. This co-authorship refers to the people that integrate for have a communities of the scientists that enjoy together, participate in different works, and for different networks. What happens if you change the nodes in the network by spins? Spin is a dipolar, in this case it's magnetic dipolar for each atom have added this spin in your network. And what happens if you change this spin by nodes? Spin have different types of interaction. Exchange interaction, dipolar interaction, Diallo-Sinsky-Moria interaction, surface, and other more. There are so many types of interaction in spin. What happens if you replace this for spins? Yeah, this is my question. The result was presented here in scientific reports in 2021. Yeah. And these are my first results about this project. And we obtained the data from Core of Science, excuse me. I can remember, Web of Science, core collection of Web of Science. And I use R as a software for that. And the data criteria was me experience. For example, here you can see this is the query for the search. This is magneto-resistant nanoparticles. Yes, this is my area. I am physics. And this is the data for that. For example, here, magneto-resistance. The first paper was in 1953. And for example, here, the number of papers for this topic was 68. Yeah. And the number of reference is selected from the end of the papers. Yeah. More or less that. And we need to divide the time for steps times. And in each time appears one number of nodes, or one number of, in this case, of new authors for this topic. Okay. And we obtain a lot of data, but just a few of the query is good. Not all data is good. Yeah. In this case, it's because you need that the process have a start and finish. Yeah. And I need to explain that. Yeah. This is the time steps. And here appears the first papers refers to this topic. Yeah. But appears here, but before other author write about this topic, and start here in the time 0. Yeah. The topic starts here, but it's so difficult that people know the topic in this moment, and after some years appears the other person that say, it's interesting, and I work in this. I want to work in this topic, and appears the others the others papers. Yeah. The papers turn famous and interesting, and they increase the number of the authors. You can see that this red line is the number of the new notes or new authors. Okay, and here the peak in the distribution. That means that here the topic is the more highest interest, and after that people say no, I don't know interested more in this topic, and the distribution fall. Yeah. This is the blue line is the number of the links. And you can see the number of links, the peak in the number of links, after the peak of number of nodes, always. Yeah. And we found this distribution. This is the line distribution here. And with this, for simulation, we create this distribution for simulation with Monte Carlo. I spin with Monte Carlo. Here, this error bar is because you can create the sample by mean random method. Okay. Okay, here. The main purpose here is to find the communities. What happened with the communities? What is the behavior of the communities? And at the same time, by the Monte Carlo method, find the domains. In magnetism, the domain is similar to the communities in authors. Yeah. And we found this paper from Son and other authors that propose this method to find communities. See, this method is hierarchical. This divides the authors according to the more highest degree, and the next more higher degree divide the network. And this method is iterative until this criterion. This criterion is the product of capacities between these nodes. At the end of this, you can see the communities. Yeah? And other criterion is the mean magnetic field. This is to generate frustration between communities, to create the borders between communities. Yeah. And by another method was the simulation by Monte Carlo. This is just for contrast the results. Real world versus simulation. And here I use the Hamiltonian. And this is a probability to locate nodes around locate the spins around of the pre-existing spins. Yeah. This is the number of Monte Carlo steps was 100,000. This is the cutoff for observables, 50,000. And I use Fortran for this simulation. This is because I need speed. Mm-hmm. And also I use the means field. This is to separate the domains according to this field. Okay. And if the mean file is around this -1 on 1, the spin is frustrated. And that refers to the people that don't have a community. It's jump the one community and another community, but not have your proper community. And the results, you can see here the data for core shell nanoparticles networks. Yeah. You can see that, you can see the number of communities according to the size of communities. Yeah. And you can see the simulation for magnetic domains. This is, the color is magnetic domains. And you can see here the number of domains according to the size. And you can see more or less these match one another. Yeah. And this is the energy as a function of the time steps. Yeah. And you can see that here there are a critical point. This means a change of phase transition. Okay? This is a phase transition between when the authors begins to do the contact with other people, but in this point, the community is consolidated. Yeah, this is the change. Yeah, here is the percolation points also. Yeah, and this is result for simulation. In simulation, you can see the same tendency. Yeah, here I use these values for time step of the peak. Yeah, and you can see the relation between peak, time of the peak, and this transition is proportional to the line. Okay. Yeah. And this slide, you can see the number of communities here as a function of the time steps. And you can see that the result is more or less have the same tendency with this for simulation. There are 3 steps here for the generate two communities. Yeah. At the beginning, the number of the domains in simulation is 0. Just here around 10, between 20 and 10 steps, you can observe the starting, the formation of domains. Yeah. But here you can see that this size of community change. This is because people jump to one another community. Yeah. Just here, it's possible to observe communities well-defined. Yeah? Yeah. In this case. Yes. And on the end, you can see here that the communities size number of the communities with this in this the number of communities established in one value. There are this means that although new people introduced in the network, no more communities appears, just vinculate to the whole communities. Okay. And you can see that in the real networks, the behavior is different until this point. That means other critical point. That's this point was characterized here by simulation, and this is the tendency of this point that transit one another. It's similar to this point here. Okay. Conclusion. My conclusion is, well, networks can be simulated with spins, yeah? And this is just for one first interaction. Okay? And the other is you can find a transition between that, and this corresponds with the reality. Yeah. Okay, it's good. Thank you very much. Excuse me. This were, you can more information about that in this repository for National University of Colombia. This is the thesis of Viviana Hurtado, yeah? And this is the people that helped me with this job. Thank you.
Now you can clap. Yeah. Thank you. Thank you, Dario. Any questions? We have time for questions. I think we have time. No questions? No? Okay. Thank you, Dario. Thanks, Dario, again, please.